Hello there, great person, and welcome to another reaction to a science video today. Yeah, we're gonna do one that is not so new. It's quite an old science video. I know about it because I've watched it once before, halfway through, I think, and then I just switched it off because I couldn't bear it anymore. But I think it's one of the, at least to my knowledge, one of the most famous science videos. So it's Dr. Quantum double slit experiment. And yeah, it's a thing. Oh god, this is gonna be bad. Okay, so this one, I don't really know where it comes from. It might be BBC and it might be this strange movie Down the Rabbit Hole, which is no, don't watch that, please. So yeah, let's just react to it. To my background, I'm a quantum physicist. I do quantum physics sometimes, not solely, but it's one of the things I do. So let's just see what this great video has got for us today, and have some fun. And oh yeah, I will pause this. So I hope you don't mind. If you do mind, this is probably not for you. So yeah. Okay, now it works.
And here we are, the granddaddy of all quantum weirdness, the infamous double slit experiment. To understand this experiment, we first need to see how particles, or little balls of matter, act. If we randomly shoot a small object, say a marble, at the screen,
You have to be very careful here, and that's the first thing to note. He started with particles. He doesn't mean that. He means like little objects, like he said, you know? So he said it. He said, let's take little objects like marbles, but they're not particles. You know, that's very, very important. I mean, you could call them particles, but it's not the particle you know from physics. You have to be very careful with what he says here. You can, it's very misunderstandable what he says here. So it's like, yeah, you just take some marbles and you throw them at a wall. Nothing more. Has nothing to do with physics particles, you know?
we see a pattern on the back wall where they went through the slit.
Pieces would have probably been the better
Now,
word.
if we
Pieces
add
of
a
matter.
second slit, we would expect to see a
Or pieces
second
of material.
band duplicated to the right. Now,
Yeah.
let's look at waves. The waves hit the slit and radiate out, striking the back wall with the most intensity directly in line with the slit.
Here as well, there's a very, very big problem, and I understand why they do it. So they try to show you, yeah, there's like here's the brightest, the highest intensity, and that's correct. Though what they don't tell you is there are little lines here and here as well, because there is interference here already because of the little edges of the slit. On every edge there is a wave, and they already have interference. So every time you have a slit, you always have an interference pattern. You will never get this one, never. You know, it's like I would have started with the double slit and explained it, and then gone to this one and then said, yeah, it's roughly like this, you know, because you would never see this one. So yeah, it's one of the biggest problems. And I think it's the question most people will get wrong, because when they are asked later, it's probably going to come. If you close one of the slits, what will you see? And then you will see no interference anymore, they will say, probably. No interference. That's wrong. You will see interference still. You can't switch that off.
The line of brightness on the back screen shows that intensity. This is similar to the line the marbles make. But when we add the second slit, something different happens. If the top of one wave meets the bottom of another wave, they cancel each other out. So now there is an interference pattern on the back wall. Places where the two tops meet are the highest intensity, the bright lines, and where they cancel, there is nothing. So, when we throw things, that is, matter, through two slits, we get this. Two bands of hits. And
Yeah,
with waves,
very big
we
parts of
get an
matter,
interference pattern
like
of
100,000
many
atoms.
waves. Good so far. Now, let's go quantum.
Oh, mate.
An electron is a tiny, tiny bit of matter, like a tiny marble.
No. No, it isn't. And that's the problem here. I think that's why I really got very wary of what they were gonna tell me in this video, because it's not. Electrons are not little. They are pieces of matter, but it's like a note as a part of a song. You know, it's abstract. It's not a real piece of matter in the sense that it's a little lump of something. It's not. And that's the point of this experiment, by the way. And I hope they will resolve it. But very important, we don't know what electrons are. So whatever comes out here, you will not know what it is. And if they show what it is, like a little ball, they will have effed up already.
Let's fire a stream through one slit. It behaves just like the marble.
That is where, yeah.
Single band.
Okay, so they do it correctly, you know? So you don't really know what an electron is before. You know, they visualize it as a light cone, which is perfectly fine. And then on the wall, you get this pattern, and that is correct, you know? So, but what you should not think is that you know what happens here and here. So between slit and screen, what happens? You know, do you imagine something, by the way? Question I'm interested in. So what do you imagine happens here? Like, do you imagine there are little balls coming out of here and hitting somewhere on this wall? That's yeah, you shouldn't do that, because that will probably hinder your learning progression, because at this point we don't know what's between, and I hope they tell us, but you don't know what's between and here.
So
you know there are
if we
electrons, but
shoot
you
these
know
tiny
nothing
bits
else.
Through two slits, we should get, like the marbles, two bands. What? An interference pattern.
Yeah.
We fired electrons, tiny bits of matter.
No, 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 no. They did it. They did what they. Oh no. So this makes it wrong. This makes it absolutely wrong. That they show these little balls. That's exactly what you try to prove, show, not prove, with this experiment, that it doesn't work like that. Exactly, this doesn't work. Yes, the interference pattern comes out, which is weird. But, you know, I like how they did that, you know? It's like, yeah, okay, so we imagine little balls, okay, but, oh, the experiment doesn't fall in line with our hypothesis. I hate that word so much. You know, it doesn't fall in line, so what are we gonna do now? And now we have to think, you know, that would have been a great approach, but now they show these balls, and they are false. Why show the balls?
We get a pattern like waves.
It's so wrong.
Not like little marbles. How?
This is so wrong. I'm sorry, this is so beyond wrong.
It doesn't make sense.
And you know why I can say this is wrong for once and not this is an inaccurate model? Because they said they're going quantum. If you go quantum, this is wrong.
But
per definition.
Physicists are clever. They thought maybe those little balls are bouncing off each other and creating that pattern. So
yes, by the way, that's good. So I would have shown that as well. So you think the pattern, the interference pattern, comes out because we think they're little balls and they bounce off each other, so they should have you know, exactly what we just saw. You know, it's just them bouncing off. Because our model currently is, our hypothesis is they are little balls. Will that work now? So it shouldn't work now because they have nothing to bounce off.
They decide to shoot electrons through one at a time. There is no way they could interfere with each other. But after an hour of this, the same interference pattern is seen to emerge.
Yes, that is one of the most beautiful results of quantum physics, I think, because it shows you can't imagine it as a particle. It doesn't work, doesn't make any sense anymore. You know, that's the point, and that's the point of the double slit experiment. You can't explain it with little balls flying through. You can't. It's just impossible.
The conclusion is in this.
I mean, you can I think there is Bohmian mechanics that can explain it, or but they can't explain other quantum stuff. So I will leave it at that. So you might argue you can explain it with paths, but will not get you anywhere later down the line. So I will not talk about it anymore here, because it would derail the conversation, I think. But yeah.
Escapable. The single electron leaves as a particle, becomes a wave of potentials, goes through both slits, and interferes with itself.
And that is correct, save for the start. He says the electron leaves as a particle and becomes a wave. No. Why? That step is not necessary, theoretically, I think. You could just say, yeah, it's a wave of potentials. And they interact as particles when they interact somewhere.
To hit the wall like a particle. But mathematically, it's even stranger. It goes through both slits and it goes through neither. And it goes through just one and it goes through just the other.
I'm sorry, I can't read the formula. I don't know what he's talking about here. I don't think it could. If it doesn't go through any slit at all, it won't have an interference pattern in the end. If it gets, it has to go through both. That's the point. It goes through both, and you can't explain why when you take it as a ball.
All of these possibilities are in superposition with each other. But physicists were completely baffled by this. So they decided to peek and see which slit it actually goes through. They put a measuring device by one slit to see which one it went through and let it fly.
And that's a good idea, just close one slit. That's what they do, they close one slit. It's not like whatever this eye is, I don't know what that eye is supposed to be, but they close one slit in the experiment.
But the quantum world is far more mysterious than they...
This is so stupid. What is this thing? This makes no sense from from a quantum physicist's perspective. This one here does not make any sense. I mean, you could say it's pilot wave theory, perhaps, but no one will say that probably because almost no one knows it. People that try to explain this stuff normally don't assume that that's the case, that it's a pilot wave. So, and it can't explain entanglement. So yeah. Anyway,
they could have imagined. When they observed, the electron went back to behaving like a little marble. It produced a pattern of two bands, not an interference.
No. I'm sorry, no. It does not. It does not. That's so stupid. If you know an experiment where this was the case and you can prove it to me with a paper, I would be quite fascinated, actually. Because that's not how you do it. This, the measuring of the slit is done in most cases either through a detector, then you actually might have it. If you use a detector that absorbs a photon and emits one as well, because then you don't have a slit, you just have two sources, that stream out photons, and so it won't make sense anymore. That might be the only case. So you would need a measuring device that absorbs the particle you put in and shoots it out again. And then it's trivial that it's the pattern of two things. But normally when you do it, as far as I know, you close one slit and you see what's happening. And then you see that there's the interference pattern of a single slit, which is an interference pattern, as I already told you before. So
it's pattern of many. The very act of measuring or observing which slit it went through meant it only went through one, not both. The electron decided to act differently.
No, it didn't decide anything. It just does things. If you measure it and absorb it, of course you would measure it. It's like, imagine it like this, perhaps. You would put another screen at the double slit. So there you would get directly after. So you take a piece of, I don't know, photo paper, whatever, you put it behind, and the electron goes through, and you measure it on one of the slits. So it's like the wall, it's a little dot, but it's closer, so it can't, can't interfere, because there's no room behind these slits. So it won't interfere, it will just hit either one slit or the other, and after that you just take the little dots from the photo, and you create electrons from them and send them out again in straight lines, so to speak. That's what the explanation would be, even though the sending out is also not a ball. You send out a directional wave, so to speak.
As though it was aware it was being watched.
No, oh God, no, it's not aware of anything. Jesus Christ. I hate that so much. It's so stupid. People think because I am conscious, my mind influences stuff in the world. No. No, it's just basic interaction. Every interaction is like this. So it's yeah, whatever. This is used very, very often to mystify quantum physics and for these stupid things like quantum healing and stuff like that. It doesn't work. Most people don't even know what they're talking about when they talk about anything there, so yeah. And it's expensive, so it's quite a scam.
Stepped forever into the strange, never world of quantum events. What is matter? Marbles or waves? And waves of what? And what does an observer have to do with any of this?
Nothing.
The observer collapsed the wave function simply by observing.
No, by measuring. That's so stupid. They even get it right sometimes. They sometimes say observing or measuring. You know, it's really like measuring with a detector, and your eye is a detector. So it's nothing like, it's not your mind, it's your eye that does it. Perhaps that's easier to understand what, yeah. Yeah, so we're done with this stupid video. Sorry. I'm sorry that I did this one. I wanted to do it. I never saw it to the end, I think. Although I remember this eye. So the last time I saw this was like 15 years ago, I think. Or when did this come out? Wait a moment. I will just switch over to this. Okay, so great. Great stuff, great stuff, great stuff. So yeah, let's look at the comments. Oh God. Patrick, I'm so sorry. Yeah. Yep. So normally I don't read comments, but I want to see what people think of this. Because this has almost 1 million people who watched it and 12,000 likes, which, yes, their animation quality for that time, when was it? When did this come out? I don't know when this came out. Yeah, I don't know when this was. I thought I saw 11 years when I watched it at the, yeah. So, yeah. I don't think your dad was a quantum physicist, mate. But I'm sure he was. He's a great physicist, I bet. But yeah. Many physicists can't even explain it, to be fair. It's really, you really have to get another mindset to really think about these things, and it's hard. And I had so many problems with doing that for so long, you know, it's like very hard to wrap your head around. And if you get explanations like this one, there are so many things that are true in their explanation, but there are central things they get very wrong, and that's so bad, yeah. How can you understand wave-particle duality from that? You can't. You think they are like choosing randomly. It's, yeah. This is actually an interesting question. So this depends, because things are quantized. So if you interact with something, either you interact or you don't. If you interact, you change energy, so to speak, or whatever, you know. Or if it's not enough, just nothing happens. Yeah, I'm so worried about this because they explained it completely. You know, the essential thing got completely lost in this video. It's so, oh God, I'm so sorry, guys. Oh, yes. This is correct, by the way. So there's a great guy here, Ilko. You are great. You are exactly right. So these effects have to be taken into consideration via when you construct microtransistors and stuff like that, because electrons just tunnel away. And I think it's even proven that your sense of smell, you know, You have these biological models that you probably know from school where these shapes go into your nose and they fit into places. That happens by quantum tunneling in part as well. As far as people, it's not that proven, but it's a very, very well working hypothesis, I think, as far as I know, you know? Yeah. Yes, Stefan, you're onto something here. Yeah, whatever. Let's just stop it here. I'm it's I don't know, you know, it's like this explanation that worries me so much, because seriously, ah, you will get a completely wrong idea of what the wave particle duality is, what it actually is. And I understand it. I mean, they did a good job in animating stuff, and they almost had it. That's the problem. They almost have it, but the crucial parts are wrong. They are really wrong. It's like saying a horse is a cow. I don't know. You know, it's like, yeah. I mean, do you know this video? Have you watched it? I don't know if you watched it. I would never show this to students. I would only show it to discuss what's wrong about it, I think. So, I don't know. So today we had this one. If you want me to react to other stuff that might not be so scientifically accurate or whatever, be my guests. Otherwise, I will perhaps do something from Kurzgesagt again, like psychological stuff. I don't know, but anyway, let's just end it here. And I hope you have a great day. And yeah, if you like this content, consider liking, subscribing, ring the bell, and yeah, I will see you soon, I hope. And take care of yourself. Bye.